Welcome back to the hyperbolic coding chamber. We are back once again with more LeetCode to battle against, more people to battle against, and it's just another day and another dollop of suffering. It's us. It's the hyperbolic coding chamber versus the LeetCode devs. It's an arms race, and they're working tirelessly to create problems that cannot be solved, and it's also an arms race for the Discord. We are working with some of the top tech companies, big tech. We have a research division, and we also have some of the leading researchers in the field. We have people such as Adam Sandler, Drake, et al. In the Discord, working on new algorithms, new ways to view graph structures, new algorithms for graphs, as well as unsolved problems. So I would say it's gonna be quite the battle. Hopefully we can win, but we do have some comments, so let's take a look. So we have, so we just started doing game dev every day. It's going to be on a different channel, so if that's something you're interested in, you should subscribe. So maybe it'll be interesting to you, maybe it won't be, but it seemed like the right decision to move it to a different channel. But this is the LeetCode channel. And then we have a comment from, I'm not really certain how to say this, but we'll say 10. And the comment says, tough. Feel strong, man. True. So yeah, I tried to upload a video yesterday on the on the game dev channel, and YouTube is dogging me. YouTube is dogging the little guy. I'm the little guy, and I can't upload a video longer than 15 minutes for some reason. So the videos are longer than that, so maybe I'm just going to cut them down to 15 minutes for now, and then hopefully it'll let me start posting the longer ones. But I don't really know what to do, so maybe I'll cut them down or just post them as is. So yeah, it's unfortunate. And then we have the legend, the man, the myth, the parable, the lesson, the beginning and the end, the Control-C ninja. New game dev, who this? True. So yeah, watch out, big gaming. Little indie is coming. The people are unionizing against big gaming to stop them, because someone has to put a stop to this, okay? So yeah, the gaming executives are hitting my line. They're telling me to stop, and I told them the Discord, we can't stop. So it is a necessary evil. So yeah, they're just going to have to step it up. So that being said, it is Friday, and on Friday we typically do a slightly shorter session. So today we're probably going to do around 35 minutes. So Friday can be our recovery a little bit. So we're going to do a little bit of a shorter session here, just so it all maps out in the end. So yeah, but yeah, so we have some problems. We did some good problems yesterday. We got to do some BST problems, so hopefully we can find some more problems to do. And yeah, I'm just gonna jump into it. So yeah, if also you should join the Hyperbolic Coding Chamber Discord, as well as check out the Game Dev Everyday channel, which is in the description. So you should check both those channels out if that's something you're interested in. So I'm just gonna jump into the LeetCode. So you have 35 minutes. A problem called High Five. Given a list of the scores of different students, items, where item sub I is equal to ID sub I, score sub I. Given a list of the scores of different students. Given a list of the scores. Given a list of the scores of different students. Given a list of the scores of different students. Items where item sub I is equal to ID sub I, score sub I, represents one score from a student with ID I. Okay, calculate each student's top 5 average. Return the answer as an array pairs result, where result sub I is the ID and the top 5 average represents the student with IDJ and their top. What does that mean, their top 5 average? Sort result by ID sub J in increasing order. A student's top 5 average is calculated by taking the sum of their top 5 scores and dividing it by 5 using integer division. So it looks like we could pretty much just Is every student at least guaranteed to have 5 scores though? Right, and there would be at least 5 scores. So it looks like we could just load this all into a set where we map an ID to the an array of numbers. Then we can sort the numbers in descending order. We'll take the top 5 numbers, take their average. I guess we can just iterate through the map then and create that value. Hopefully we can return the output. I don't know. We have to sort the output, so we have to sort that again. Then we have to sort it by ID in increasing order. So I think we could just do that. So we could just create that map that we're looking for. It's going to be a map of number to number array. And then right now we have that map that we're setting up. Now we can just iterate for a const tuple of items, and I guess we would have ID score, right? We'll just say R is equal to if the map we'll say const R is equal to if the map, right, already has an array for that score, then we're just going to do map.get ID, right? And if it doesn't have it, we're going to set it equal to an empty array. Then we can push that score onto the array. And then from here, the goal can just be to set the ID to that array. From at this point, I think we can just iterate over ID, right? We'll have scores of map, and then we can just sort scores, and we'll sort it in descending order, and we'll say we'll take the top 5 scores, uh, 0 to 5, right, dot reduce, right, and we'll just do a plus b, right, divided by 5. And then we'll have our output, which is also going to be an ID, right, a number, and we're just going to have an array of them. So from here we can say that output dot push ID, and then we can say top 5 average, and we'll just make this a tuple. So we got 2. They got 280. We got 289. They got 288. We got 288. We divide it by 5. Maybe what we'll do is we'll floor it. Oh, right. And the last thing they wanted us to do is then we can sort it, the rest of them by ID. So we'll do that here. So it looks like this was okay. We have to do linear iteration over items. Then from here, we sort each subarray of items of the scores, which is basically n log n. So let's say let's say n plus n log n. And then we sort the output again. I feel like this would be n log n with linear space in the map. N is the number of n is the number of unique students, or n is the number of elements in the n is the number of elements or tuples in the array. But let's check the solution and log in. Java code is doing a lot. For item. So what's the intuition here? Since you have to so they created a custom comparator. Okay, now it's sorted and they iterate through. I is less than n. So I is not 0 to. Oh, this is actually really clever. This is actually really clever. I see. They sort it so that this way. I see. I think you saw them with especially the same time complexity. That's really clever though, using the comparator like that, because the elements of the same ID all next to each other, but in decreasing order, so they're already set up for you to take to process the first 5. That's really clever. So we have range sum of BST. Given the root node of a binary search tree, and two integers low and high, given the root node of a BST, and two integers low and high, return the sum of values of all nodes with a value in the inclusive range. So what we could do is we could just turn this into an array, and we can have a traverse function which will pass in root and array, and this traverse function will take a node. It's going to be a tree node or null, and it's going to take that array. It's not going to return anything. If the node exists, we know that in order traversal of a BST gives you an result, or an array sorted in the correct order. So do traverse node.left with r, and then we'll do r.push node.val, and then we can do traverse.right. Now I have an array sorted correctly. Then we can say sum is equal to 0. We'll return sum, and then for let I is equal to 0. Or we could just do it like this: const num of r if num is greater than or equal to low, and num is less than or equal to high, then we'll do sum plus equal num. So this would be linear time to traverse the tree. So there's linear space to create the array. There's no follow-up regarding it, so I always forget you can do in order traversal with a while loop. That way it would actually take no space. That's actually clever. Oh no. Well, in this one we take linear space. I see what they're saying. Yeah, in the other version we would take linear space on the stack with the recursion stack. But with the other one, we only take linear space in terms of the array. So you have minimum value to get positive step-by-step sum. Given an array of integers nums, you start with an initial positive value, start value. Given an array of integers nums. So if an array of integers, you start with an initial positive value, start value. In each iteration, you calculate the step-by-step sum of the start value plus elements and nums from left to right. So you're just asking for the sum of the array. Return the minimum positive value of start value such that the step-by-step sum is never less than 1. Ah. I thought I understood this problem until we got to this last part where it says we have 1, -2, and -3, and the answer is 5. So let me reread the problem. Given an array of integers nums, given an array of integers nums. So we're back. Given an array of integers nums, you start with an initial positive value, start value. In each iteration, you calculate the step-by-step sum of start value plus elements in nums from left to right. Return the minimum positive value of start value such that the step-by-step sum is never less than 1. What do I mean by step-by-step sum? Oh, the number carries over. So we have 4 minus 3, we get 1. 1 plus 2, we'd get 3. You get 0, so this is bad. And then 0 plus 4, we get 4. Flip it right. So let's just say if we summed all these numbers up, is there a pattern here? Right? If we do -3, plus 2 minus 3 plus 4 plus 2, right? What do we actually get? What do we actually get? Let's just check. So we'd get -3 plus 2 is 1, is -1, plus -3 is -4, plus 4 is 0, plus 2 is 2. Let me just check that though. We have -3 plus 2 plus -3 plus 4 plus 2, and you get 2. I think you could brute force this and just count all the numbers. That would take, it's unclear how long that would take. The fact that they get carried, how can they get carried from some step to step is crazy though. Get carried from step to step is crazy. If you choose start value equals 4, in the third iteration, your step-by-step sum is less than 1. If you choose start value equals 4 in the third iteration, your step-by-step sum is less than 1. I think we can do this actually. What if we created a different array? For example, something like a DP array, where instead of what was actually in the array, you'd have all the numbers in the array, you would have the sum of the numbers in the array subtracted from the position. So we know that the sum is 2, right? If we sum up all the elements in the array, right? So we'd have 2 minus -3, which would give you -1. We have 2 minus 2, which would give you 0. We'd have 2 minus negative 3 should give you 5. And then 2 minus 4 should give you negative 2. And 2 minus 2 should give you 0. And then we can just, maybe we could just choose the largest number in here, because that would be the largest. Largest number in here. So let's try another one here. Right? We know that the sum for this one would be 4, right? Because negative 3 plus negative 2 gives you negative 5 minus our plus 1. Wait a second, let me double check. We get 2. 2 minus 3 is negative 1. 2 minus 2 is 0. 2 minus, all right. So we'd have 4 minus 1 gives you 3. 4 minus 2, 4 minus 2 would give you 6. 4 minus 3 would give you 7. No, wait, something's off here. I did this wrong. The sum of the array is 2. If we do 2 minus negative 3, we get 5. 2 minus 0 gives you 2. 2 minus negative 3 gives you 5. 2 minus 4 gives you negative 2. 2 minus 2 gives you 0. Okay, so it seems like there could be a pattern here. 4 minus 1 to give you 3. 4. Wait, what is going on? I cannot do basic math. The sum would be negative 4. So let me redo this. Negative 4 minus 1 gives you negative 5. Negative 4 minus 2 minus negative 2 would give you negative 2. Then here we would have negative 4 minus negative 3 would give you negative 1. So that is promising. So ideally, if we take the largest number that is needed, that is less than 0, or if we just take the number that is the furthest distance from 0, yeah, if we take the number that is the greatest distance from 0 and add it to our number, or we should just be able to find the number right that is at that point. At least that's what I'm thinking. That's what makes the most sense to me. But I feel like I'm messing up basic addition here. You have negative 6 plus 6 gives you 0. The sum is 2. Negative 3 minus 2. Yeah, and I'm wrong again. Negative 3. No. Negative 3 minus 2 gives you negative 5. 2 minus 2 gives you 0. 2 minus negative 3 would give you 5. 2 minus 4 would give you negative 2. Minus 2 would give you 0. Right, now this makes more sense, which means the maximum correction we need is negative 5. So the answer here would be would be 5. Then for this one, the maximum correction we would need would be 5. Then if we take this one, right, the sum is equal to 3, which means we would get 3 minus 1, which would give you 2, and 3 minus 1. Three minus 2, which would give you 1. So it looks like we can just take the absolute value of the smallest number here as our output. So we can write that function. So let's write that function. Bro, I am like for some reason none of my bindings are working. Let me just refresh the page. Maybe something went wrong. So we should just be able to take the sum of the numbers in the array. And what is the array called? It's called nums. So we'll just use reduce to reduce it to one value. here we'll create a new array. It's just going to be an array of numbers, and we'll do for const num of nums, right? We're just going to do r dot push sum minus num, and then we're just going to want to get the smallest number in the array. A false number in this difference array, and we'll say this is going to be math.min of min is equal to the math.min of min or the num. Then we can return math.abs num. I mean math.abs min. I'm going to print that difference array just to check something. Here we output 2, which doesn't quite make sense. If we output 2 here, this should make sense. If we output 2 here, I think I said one more thing that I forgot to say. Or we miscalculated. 2 minus 5 gives you a positive 5, not negative 5. const num of r. It seems like we need one more test, which would pretty much say if something is if the array has a negative number in it or not. And we can, my screen is flickering just a little bit. We can actually do all of this in one go. And we'll just say if num is less than 0. Is equal to true. Now, if it has a negative number, then what we'd like to return is the math.absolute of min. Otherwise, you want to return the max. Oh, I mean, if there's no negative, if it's positive only. Yeah, it looks like we overfit to the examples they gave us. Wait a second. I think we overcomplicated. We just want to know that the step-by-step sum will always be at least 1. So couldn't we just take the sum as we're going through and then just add the difference to make it 1? Let me try one last approach. We'll return start value. I have a sum that we're working on, const num of nums. Which means what start value should we start at? If we start at 0, we'll start the sum at nums sub 0. And we'll say if num minus, if the current sum minus num is less than 1, then we need to add to the sum, right? Sum plus equal sum minus num. So we'd start with 4, and we'd say, okay, 4 minus 4 is equal to 0, which is less than 1. So we need to add 4 I guess how far away it is from num. now that I'm thinking about it, it's not what we're looking for. It's start value minus num sub 0 sub 0 sum plus equal math. We could do start value actually, yeah, we actually don't need to keep track of start value. We pretty much just need to keep track of how much we have to add to the sum to make it different. Then we'll have something like num sum should be equal to 0, and we would basically just do num sum plus equal num, and then we should just have to return the absolute value of num sum minus sum. So if we just check this really quick, sum would start at 2. 2 minus 2 gives you 0, which is less than 1. So we'd have to add at least. So we'd say, okay, 2 minus 2 gives you 0. 1 minus 0 is 1. So add 1 to the sum. And then also sum plus equal num. So maybe we can actually start this at 0. We'll say 0 minus num is -2, which is less than 1. Which is fine. Then we'll say, okay, well, sum minus num, 0 minus num gives you -2, right? And 1 minus -2 actually gives you 3. So we'll take the absolute value of that, and we'll get 3 to start. So our sum will have 3, and the num sum will have 2. There's like a small bit of competing priorities, which is messing me up here. But we'll stop there for today, and yeah, we should be able to figure this one out. We're just I'm a little crunched for time, and I'm trying to go too fast, so we'll just stop there.